just the commands here for the installation of Mininet and Rio. These are for Ubuntu, whichever Linux you're using. It's not too difficult, too complicated. If you just, there are a few dependencies for, especially for Rio, but if you run these commands, you should be fine. So you'll have the slides. If you're installing Rio, just run these commands. Okay, now let's take a look at how we can create topologies in Mininet. We have three main ways of doing it. Mininet provides a script mn, a utility. You can simply use that to create a topology, right? So you can take a look at the help of this utility here. So you can see that there are a lot of options that are provided. If you want, so for example, if you want to choose a certain type of switch, which Mininet provides a few options. So if you're using a default, that will be an OpenV switch. You can use other types. If you're not aiming to use SDN and you just want your standard routing devices like Linux Bridge or like those, so you can use those. Mininet already has those available. Similarly, you can choose the type of host, the type of controller you're using. You can choose from different link options. So a default link would not have any controls on it. Will use the maximum allowed bandwidth and that's it. But if you want to limit your bandwidth, for example, for monitoring network devices or traffic management or those things, and you want to experiment with different bandwidths or delays on the links, you can use TC link, and there are other options. And then if you're using a topology which is not just like you have a linear topology, you might have heard about these before, where you have switches connected in like a serial series of uh, arrangement. Then you have single topology, where is one switch connected with multiple hosts. You can have a tree topology and so on. So there is all these options that are provided by default. If you want to create such topology, all you need to do is you call the mn script, you use the topo parameter, and you give it an argument. So for example, we just want a minimal topology, so you just run it with minimal. This output here shows you the steps that are happening in the back. First of all, it creates a network instance, which is a Mininet network, and then it adds different nodes to it. So it adds a controller node, it adds the host nodes. In this case, minimal is just two hosts connected with one switch, so it adds two hosts, and then adds the switch, adds the links between switches and hosts. Okay, and then finally it starts up all those nodes, so configures the hosts, controller, and switches. So these are the steps, and then in the end you can see a command line interface has been opened here. Okay, now you can use this command line interface to run a lot of different commands. Some of these are provided here. You can see that, for example, there is a command ping all, which will send pings from all the devices to each other. For generating traffic, iperf is a common tool, so you can just use that. So if you want to create iperf, you can just use iperf and then give the name of the host. In our case is h1 and h2. You can do that, test that. Okay, and then these are just some of the standard commands, but in addition you also have an option here to open a terminal for the host. Okay, so we have a host h1, we can open a terminal for that, and from this terminal you can run whatever command you want. So although it's a process, but it has a shared memory as well, so you have access to whatever you want to do. So for example, you're testing some server and client based on video. Okay, so you want h1 to be the server, h2 to be the client, so you can run your server and client code on these hosts, and since it's an emulation, it will actually transfer packets from one node to the other, and you can see all that, right? And you can do whatever you want with it. So, and then finally when you're done, exit the network. Okay, so we looked add some of these options here, the default options that are provided. You can go through them and hopefully you'll find something that's useful. So that's one way of creating the network. Okay. The next thing you can do is you can create a custom topology or a node type. So as we can see that we have some sort of some types of switches or hosts, controllers, topology, but that might not be what you actually want to test with, right? You might need a topology that's different. So as an example, just in this figure here, I created this topology. It is a tree topology, but you know, it's something that if you want to create, I can show you how to do that. Of course, one way would be just to simply use the tree topology that Mininet is providing, but we'll just look at how to do it with a custom approach. And, and yeah, even if you want to do it, so in this particular example, you have the tree, but in the first layer you have one node, in the second layer you have three nodes connected with that, and then in the next layer you have two connected with each one of them. So it is a tree, but it's not like a standard tree that you will get in Mininet. So to create such topologies, you can do it by defining custom files. Um, so and topology is one example. You can also create custom nodes, but let's look at how to create a custom topology. Okay, so from mininet.topo you will import the topo class, and then you will define your own class. Okay, you will initialize it with the mininet topo class, which in this case we have done, and after that you can easily add switches, hosts, nodes, links, whatever you want to it. So for example, in this particular case, yeah. Let me take a look. I'm not sure.
Try shift or something and then to scroll or to control. And then
Yeah, I know. They might be in the zoom option here. No, I don't know how to do it.
Generally, preferences window. File. Yeah, settings. Does have editor? Yeah.
In the editor, font. Okay, that's better. Okay, so the topology that we're trying to create is the one that we saw in the slides, which is kind of like this. Okay, so what we have here is 4 switches. How do you add them? You can simply call the add switch method of that's provided by Mininet and give it a name. So in this case, we call them S1, S2, S3, and S4. So it takes the name as a parameter, and it also takes some other options like defining the type of switch. As an example, Open vSwitch, or if you're not using ST and you want a Linux bridge, you can define that type here. Okay, and then what it returns is an instance of that switch that you of that node that you just created. So we create 4 switches. Uh, we're not actually creating them, we're adding them to the topology in this file. And then similarly, we have 6 hosts here. We add 6 hosts like this. Again, the parameters would be the name, you can have IP address, you can have default route, and a lot of other things that you can do. For host, there's also an option to have a CPU limited host. So for example, if you want to If you don't limit the CPU for the host, it uses whatever your CPU of the machine is. If you want to have a certain limit on it, you can set that as well. So there's different options that you can do. IP address by default, Mininet uses the same range as I've used here, 10.0.0, but you can choose whichever you want. Okay, and then once you have added the switches and hosts, the next thing is to add the links. Again, it's a simple self.add_link method, and you pass two nodes to it. Okay, so we have links here S1 and S2, S1, S3, S1, S4. So you simply pass the instances of these inside in the method, and it will add those links. Okay, so the class is defined here, and then I create an instance of that class. So I name it topos, and I give it a name which is in this case my topo. We have one line down here, we'll look at that later. So once you have the topology defined, you run the same mn script again. You pass the custom file that you have using the custom argument. Okay, and then inside that file we have defined a topology which we named as topo, my topo. So you use the argument. So just like you were gonna create a linear topology, now you can create the topology whatever name you used. Okay, and if you run that command, you will see that Mininet created the network, added the controller. By the way, so far we're using the default controller. We'll see how to use Rio later. And then you add the hosts. In this case we had 6 hosts, 4 switches, all the links, and then it configured them and start them. If we do a ping all, we can test the ping working for all of them. Okay, so ping all sends ping from each host to every other host. So you can see that it's all working here. So that's one way of creating custom topologies or custom nodes, right? So that's the second thing. And then finally we have the third way, which is creating the network script, a whole script. And that's probably what you will be doing if you're experimenting with Mininet. So it's a good option to have a Mininet MN launch script, but what you probably need is a complete network script in which you can automate everything. So you want to run a client automatically. You don't want to have to go to the command line interface and then start the client application from there every time. So for your experiments, you'll probably create a network script. I have a very simple network script here as an example. It creates exactly the same thing as we have seen here. Okay, the same network, the same topology that we created, but using a complete network script. And since it's a Python script, the way you run it is simply Python, and you give it the name of the script. Okay, so in this script, I have imported a few things from Mininet, the Mininet class itself, and then some nodes you can import. We're not using these, but I just wrote it just to show you. So you can import different types of nodes, controller, remote controller, whatever you want. You can import the command line interface if you want, and similarly you can import topologies or whatever you want to use the default Mininet things. You can import those. I have created a function here, my network. So these are basically the exact same steps that you saw happening when you ran mn script, right? So if you look here, these were the things that were done to start and configure a network. Now that we're creating our own script, we basically use the Mininet API and we perform the same actions using the Mininet API and the functions methods that are provided. So you start by creating a network, simply like that. There's a lot of default a lot of parameters that you can use when initiating the network. I'm not sure if I have internet, but I have opened the Mininet API here, the documentation of the API. It's very well written. You can go through it and find whatever you're looking for. Yeah, so these are there's, as you can see, a lot of functions that you can use. You have a list of all these functions, so go through them and see what you want to do. But here we're just creating a very simple script, and I'll show you how. So you start by creating an instance of Mininet, then you add a controller to it. So when creating the topology, you added the nodes to the topology. In this case, we're creating the network itself, so we add our devices to the network. So net dot add controller, and I give it a name C0. Okay, then I add the switches net, and the function again is net dot add switch, and then I'm adding hosts. Just to show you that it's a simple Python script, I've just run a for loop here. So in this file here, we simply used rows, h1 to h6 like this. Over here, I just used a for loop. So this is to give you an idea that you can make it as dynamic as you want. So I just ran a loop, used the name as h, and then the integer next to it, and used similar thing for IP, and then I added those hosts to the network. Okay. Then you can add links using the add link command. Now, one thing to note here, when I was adding hosts, I didn't create an instance of those hosts, right? So we have S1, S2, S3, S4 over here. As I mentioned before, for the add link, you have to pass it the instances and not the names. Okay, for hosts, I don't have those names here. So what I need to do is I need to get those instances from the network. And the method to do that is get node by name, or there's an alias, simply get. So you pass this method a name, and it returns you the instance, the node itself. So for these hosts over here, I call this function, I get back the instance, and then I create the link between S2 and in this case H1, H2, H3, and so on. Right? So the nodes are added. The next thing to do is start the network. So if you look back here, you can see that Mininet was configuring host, starting controller, starting switch. So to do that over here, what we're using is net.start. Okay, so when you start the network, it will basically initiate the processes, the sockets, all those things. And then in your script, networks, in your experiment, you will probably do whatever you want to do after you start the network here. Right now, I'm not doing anything else. All I'm doing is just starting the CLI. Okay, and you just simply call CLI and pass it the network variable. Once you will be done with your experiments, finally you will stop the network using net.stop. So that's the function. In the main down here, I simply call that function. Okay. So to run that, you do sudo. And by the way, Mininet always needs to run as sudo because you're creating network instance interfaces and then processes and those things. So it has to be always with sudo. And then you simply pass it the script. Okay. So as you can see, we got the same things happening here. We added the controller, added the switches, hosts, links, and then starting the network, which means configuring the hosts and starting the controller and switches. Okay, if we do a ping all test, we can see that the pings are working and everything is working fine. So this is a very basic example of how you can create a network topology and then you know, run some commands on it, which for now we're just running ping, and as I mentioned before, you can also run iperf and other commands, but this gives you a basic idea of how to create network scripts or topologies using Mininet. There are a few examples that Mininet provides. If you go in the Mininet folder, you have a folder called examples, and there's a lot of different examples of what you can do with Mininet. So for example, as I mentioned before, you have an option to link your emulated devices or emulated hosts with actual hardwares. The file for that would be somewhere here. HW interface. Okay, so this gives you an example of how to do it. So there's a lot of things that you can learn from here. There are a few other utilities if you're trying to show a demo or show a graphical interface. So there are two utilities that I can show you very quickly. One is called Mininet. This helps you to create topologies using a graphical interface. So we saw how to write script. That's probably what you will do, but just for a quick start, you can use this to create topologies and then set different uh, values for different hosts and those things. Like it provides you some options to configure the network. So it can sometimes be helpful. Another one I can show is called Mininam that this is one that we developed in our own lab here. What this does is it displays the topologies that you create using your custom scripts or network scripts, and then also display the traffic that you're generating in your network. It can be very helpful if you're demonstrating your work, or if you're presenting your work somewhere. So it can give you a very good idea. It also helps you understand some concepts if you're trying to test your network with some basic examples and you're stuck somewhere, you don't know what's happening inside the network where the packets are going. You can use this utility. The way you run it is exactly the same as you run the MN utility, or you can also import it if you want, but if you're just running it, just do it the same way as you would do use the MN utility. Okay, so it has to be okay. So the same topology we created in the custom file, and you can see that topology created here, and that's actually what the last line down here was for, to set locations. Okay, so just to set the locations of these devices on your graphical interface that opens up, you can use a command like this. If you create any traffic over here, so let's say I send ping from H1 to H3, you'll see the packets flowing in this utility. Okay, so I send two pings, you can see them from here, and then there's different options to configure how you want to see. You want to see real time, color coded, with IP address. You get a lot of statistics in here as well. There's a lot of options you can look at. So this was just a quick introduction of the utility. So that's, I think, pretty much what we have for the Mininet. If you have any questions, you can ask me, and then for the next part we'll move to the remote controller, which in our case will be real.
So this Mininet API is
Yep.
available in Python.
Mininet
Because we were
API
importing all
is available just on this link. You just Google Mininet API, you'll get this one. Since Mininet is all in Python, so
Okay.
yeah,
So you can easily import all the classes and stuff.
you can, yeah, kind of like we did here. Right, so these were the things that I needed to use for this particular. Mostly I just needed the Mininet class itself, and the CLI is something I used. I set the log level info, so I imported all that from Mininet. Other than that, you have the options to import all these other things as well. Okay, the topology, the links, whatever. Any other question?
So we should be able to take down any of the nodes in the mainnet from the commands and then test again. Like when we create all are working fine, when we did ping all, everything worked. If we wanted to disable few, then we can just manually disable few of them.
Yes, yeah. So for example, you can do things in runtime. You can change the topology. you will again use functions like add switch or add host or remove host. I think it's called delete host, del host. So you can use those to remove some hosts in runtime. So that would happen if you're writing a script, that would kind of happen after you start the network. You still have that option. And then if you want to modify links, for example, if you're using TC link and you want to change the bandwidth after every, let's say, 5 seconds, so you can use that. Okay, and you have all the methods defined in Mininet for that. Okay, so let's move to the remote controller.